Now that we have our design, we start writing the software for the MicroBlaze. The MicroBlaze Zynq, like always, have examples for us. Now the examples are in the Zynq installation folder, Vitis, version, data, embedded software, Zynq processor, LT, labs and drivers. And here we can find the INTC examples for the intercontroller. Now those are examples. Sometimes the CPU itself generates the interrupt, sometimes they ask for a UART. So I summarized everything here for you, so we can work this without the examples, only the necessary functions. Now the stages we need to do to configure the MicroBlaze interrupt controller are: first we need to initialize the interrupt controller, then we need to connect the interrupt handler to the interrupts that we have, then we need to enable the interrupt, start the controller, then we need to initialize the exceptions table and we need to connect it to the interrupt controller, enable it, and then we will do a while loop, so the MicroBlaze will keep going in a while loop until it got an interrupt. We'll start by creating application project. We'll use our XSA. We go to our folder, to our software folder, and take the XSI. Now we call this platform MB init for the MicroBlaze. Now we need to write this MB int software. This is what we call our application. We'll address it to the MicroBlaze and we'll create an empty application. We'll create a new file. We'll call it MicroBlaze int software.c, and we'll start writing. We start with the includes. First we have the X parameters, as we usually do. Then we have the X int controller header and the XIL exception here. Now in the XIL int controller header we have all the functions here, and we have two structs, one for config and one for the interrupt controller itself. We'll use the interrupt controller itself. We state it as static. And we'll give it a name INTC. Now this has to be in the file because it's needed all over the file. The next thing we need are the two handlers. Here are the name of the handlers, and we need to write them. Now we want to write, for the handler we need a counter in the software to count how many time was the button press, either one of them. And in the handler we'll increase it by 1. And since the MicroBlaze doesn't have a UART, we use a GPIO. So we go to the X parameters, we'll take the GPIO address, here it is, and we'll make a pointer GPIO to that address, and we'll use it in the header. For the first interrupt, we'll go to 0, which is the RGB, and we'll put in count. And that's our handler. Now we'll have the same for the second handler. Just we'll put it to 2 for the regular LEDs. So these are our handlers, and they're declared, and we're ready to go. So we'll start the main. And we'll add the main with return. And we start writing. First, we need to initialize the interrupt controller. Here we have a function for it, index with the device number. Here, now this is the pointer for the interrupt controller. We need to address it as pointer, and the device ID is here in the interrupt controller. In the X parameters, we have the device ID, here, and we address it. So this is the initialization. Since we have it, this function returns a value, we'll use the status, and we'll add an if then initialization was not successful. Okay, we'll use this quite a lot. Next, we need to connect the handlers to the interrupts. Now we have a function for this too. Again, it returns an it, so we will put the status and the fail if, and again we have the interrupt controller pointer and the ID. We need the ID again from here, which are the ID as so here. So this is the first ID of the interrupt, and we need the handler. So here is the handler. For the callback, we have the ID to return to the number of the interrupt. Next, we'll just need to address the second interrupt. So it's the same pointer, but now we need the second interrupt for this parameter and the second handler. And that's it. They are both connected. Now we need to enable it, enable the interrupts. So again, we have a function enable. This is a void function, so we don't need to have a status. Again, we need the pointer for the interrupt controller and the ID number. And we need the same for the second ID. Next, we start the controller. Again, we have a function. Again, we have a function with a status, with the interrupt controller pointer, and we have a mode. Now the mode here we can see that the start function has two modes, simulation mode and real mode. Since we have real interrupts, we will use the real mode. So it will actually transfer the interrupt to the CPU, to the MicroBlaze. So that's it. And now we need to address the exception table. For this we have function here. This is the IXS exceptions. First we have to initialize it. Here it is. Then we need to register the handler that we provide in the intercontroller pointer. So we'll take this. Again, it's a void. This is actually a constant function, which the parameters are quite constant depending on which CPU you are using. The the exception handler here is a function which is a little different from MicroBlaze to Zynq. And here we need the pointer. So again, we'll take the interrupt controller pointer. And that's it. The rest is to enable the exception table. Here it is. That's a micro, we just use it. And that's it. Our exception table is ready. The only thing we're still missing is the while loop. We put the MicroBlaze in a while loop to it finish the configuring the interrupt controller, and it's waiting in a while loop for one of the interrupt to be pressed. So this is the software for the MicroBlaze. And we only have to save it and compile it. And we're ready to move to the Zynq. This I will do in my next video.